Welcome back to more fun with loops. We've been talking about the following concepts. We talked about the while loop. We've talked about the do while loop. Both of these are what we call conditional loops. We use these when we don't know how many times something's going to run. For example, we're waiting for the user to give us valid input. We're letting people select until they decide they don't want to do things anymore. We're running until a total gets to a certain value, but you're not sure how many values it's going to take to get there. You're reading a file until you get to the end of the file, but you have no idea how many things are in a file. These while loops and do while loops are perfect for that, this conditional run until you get it done kind of thing. As a side note, by the way, files, even though you can open a file and count and read how many things are in it, you should always assume that you don't know. Unless you've been specified, get the first 10 elements out of a file, you don't really know how many times or how much you need to do to process a given file. On the other side of conditional loops, there's another one which is called a count-controlled loop, which is a loop that runs for a specified number of times. Do it 10 times, do it 5 times, do it 6 times. These things are called for loops in C++. Now, a for loop has the following structure. It has the for with some initialization, some terminating condition to test with, and then some count control piece to update the loop. You can do multiple things inside these, but this is the basic structure of a for loop. Initialization, test, count/update the thing. As always, like an if or a while, you can run it for one statement, but generally speaking, in these classes, we like to run it within a block. Just makes it safer for us. You don't save anything by taking those braces out again. So a quick one, just to show you how for loop will work. Your initialization piece can be as simple as just setting some variable you've already got declared to a value and then starting off, or actually creating a value. So let's show the first one. So if I declare an integer value called count, my initialization would be count equals 0. My test could be, we'll run this 5 times. Count less than 5. And then since I have an update condition here I'm just going to increment it by 1. And that would give us, oops, my fault. That will give us the basic structure of our for loop. So we have a count-controlled for loop. It's going to run 5 times, 0, 1, 2, 3, 4, and then stop. And if you really want to think about it, this is how it works. Does the count equal 0? We started off there, so yes. Is the count less than 5? Yes. Execute the statement inside the block or the next line. And then once you've done that, update the loop and then test it again. So 0, print 0. 1, is 1 less than 5? Yes, print 1. 2, is 2 less than 5? Print 2. 3, is 3 less than 5? Print 3. 4, is 4 less than 5? Yep, print it. 5, is 5 less than 5? No. We don't execute this, we drop out. And if we run it, you'll see it did exactly that. It ran 5 times, 0 through 4. Good old computer science, starting thing was 0. 0, 1, 2, 3, 4, and then it tells you the loop is over. As a side note, and this is kind of interesting to look at, look where count ended up. Count actually ended up with a value of 5. So we can see that we actually incremented that last time and then tested it here. So as a side concept to think about, when you're running things a certain number of times, generally speaking, the default format is to start at 0 and test for less than the number of times you want to run. I also say that if you're going to be doing a lot of things with this number of times you want to do stuff, you probably should come up here and put some sort of constant value in there to use inside here. So now you know exactly how many times it's going to run. Now, if you need to, by the way, this by the way, because of the way it's structured, says I need this value outside of this loop. Okay, I can actually print it out down here and use it. This is not always the case. Sometimes you want loops just to run for a certain number of times, but you don't really care about keeping track of the count of things. So in this case, we can say not only can your initialization initialize a value, it can also declare a value. Watch. And there we go. This will declare a counter to run this number of times. But the side effect of this means that because of the way things are declared, this count no longer exists. So you can't use it outside of the loop. But our loops can have either external or internally declared variables. We will take this away just to show. It still works, just this line wouldn't work. So a for loop is, again, a count-controlled loop. We know how many times we want it to run. We know that we want to be able to do something inside of it a certain number of times, get 5 values from the user. In which case, then you can actually have all kinds of count combined information there. But do it X number of times. Sometimes we want to keep track of how many times we've done it in terms of maybe we want to keep track of a counter or something else. Other times we don't. Now, just as kind of a fun thing to do, let's say we were doing this, we want to get 5 grades from the student. So inside the loop, you may actually say, you could do something like this. Enter grade and then do count plus 1, which basically doesn't change the value of count, but it adds 1 to it for display purposes, and then get the grade. Of course, we'll need a grade, so we'll put one up here. That'll give us a grade. And if we were actually going to get 5 grades and do an accumulation of things, we might actually want to have a total. So then we can come in here and say total. That adds it to the grade. And if you remember not too many lectures ago in terms of the videos we've done, right here you could actually put in a test to make sure that the grade is of the appropriate value. We're doubling down now. So you can come here. We've done our preload right here. So before we actually do any kind of totaling, we can do this. You can actually give them an error. No, we're skipping the fail conditions. But you can keep running a loop inside a loop until they actually give you a good grade and then add it up. So this is a nice way of testing to make sure that things work. And then down here at the bottom, we can actually, we'll just modify this. We know how many times we wanted it to run, which is 5. So that'll give us the average grade. Let's see if this works. So we'll put the first grade in. We'll put the second grade in. We'll finger it and make a mistake with a negative 22. Oops, we didn't do that right. and then you'll get the average grade. So you can see how we've used now the use of a counted loop, the for loop, and a conditional loop to test, because we don't know how many times the user is going to give us a bad error or a bad grade, but we've now doubled down. We can now count the number of times we want something to happen while making sure that when something bad happens, we can run it until it's fixed, and then use that to produce some information for us. Hope you've had a good time with this one. Have a great day.